So I want to kick off the discussion with a question to you. If you had to describe in one word the shape of the vocal tract, the geometric shape, in its simplest terms, to say a 5-year-old, what would you choose? What word would you choose? Tube. Tube. This is Sean McCarthy, everybody. Sean said tube. Does that sound pretty good?
Works for me.
Works for me too. So we've got our tube. This is, again, a grossly simplified version of the vocal tract. You've got your air shooting into it from, or I should say, released from the lungs into the vocal tract on one end, and the output of the system is the mouth. If we were going to add another feature to our idealized model here, what might it be? What might be the first obstruction in the airflow be?
Of course, the valve.
Yes. Yeah. The glottis is the term for the actual space itself between the vocal folds. And Sarah actually used the word that I wanted to use, which is that I want you to think of the vocal folds as a valve. It's a two-way valve. Fortunate for us, since we can breathe. We can breathe in. The valve is open, and we can close it with a glottal stop. There's one other feature I want to add to our system here. It's at the end of it. What would that be? Lips. Yeah. So as you can see, the airflow is restricted in a couple of places. And this is really important for, well, does this start to look familiar to you? Turns out a lot of the same features apply. If you read about high-performance mufflers like I do, you'll see the word back pressure in advertising. Turns out this word is also used in the research of Ingotisa and that story. This is the key ingredient of the whole thing that I want to convey in this part of the presentation, is that there are two volumes of air in this system. There's one volume of air below the glottis, and there's one above the glottis. They each have their own pressure, which varies constantly. So you read about, and we speak about subglottal pressure below, and supraglottal pressure above. It's this supraglottal pressure, this back pressure, if you will, that's really the important thing in this line of research on the semi-occluded vocal tracts. And that's because the valve, when we're singing at a high pitch, trying desperately to hold on, we're experiencing a lot of subglottal pressure. And it turns out that when you add pressure above the glottis, it tends to abduct them or open them like this. That equalizes the two pressures. It releases some of the tension that we feel when we're trying to deal with this subglottal pressure. That's the reason that humming a semi-occluded vocal tract is easier to do. The next part of the whole story is another part of the anatomy. And you've probably never seen this word before. I've never seen it. But it refers to the very first part of the vocal tract. In other words, the part that comes right after the glottis. You know those those Chinese finger traps that you get at the carnival. You put your fingers in and you pull them apart. I like to think of the epilarynx rather as kind of like one of these tubes. It can be lengthened, and when you lengthen it, it gets narrower. It's about an inch long normally, but we classically trained singers have learned to comfortably lower the larynx and raise the soft palate. It stretches out that part of the anatomy. And this is my opinion. When you see references in the literature, historically speaking, to the open throat technique, I think this is what they're talking about. We now know that this tube can be stretched to about 3 centimeters. Guess what? That tube is the singer's foreman, makes the singer's foreman pitch. So it's a pretty important part of our anatomy to us singers. And in the semi-occluded vocal tract research, it is important. First of all, let me show you just a couple of pictures to give you a better idea of the lay of the land here. As I said, it's the very first part after the larynx. Here's a picture from Gray's Anatomy. If you look right here, here's the glottis, the vocal folds on either side. So this right here, this very first part after the glottis, we're looking downwards at the head, by the way, the tongue's up at the top, would be the epilarynx, epi meaning above. And here's this cool picture from Dr. Story's article. I think it's in your bibliography, in your packet, from 2003. This was generated with one of those techniques I mentioned. And this is not part of the, this does not have any physiology in it. This is just airspace. I love this. It's really cool. You can easily see that the narrowest part of the air space, whoops, is the epilarynx, right? With the exception, maybe with the lips. In this particular image, the lips look fairly close. So you may have already seen from the next slide that Tietze's theory, Ingo Tietze's theory, is that the epilarynx replaces that volume of air that we looked at before. In other words, it creates its own little volume of air above the glottis and helps us. This is how we deal with the tremendous subglottal pressures of classical singing. And the therapy, the straw therapy, comes in, which we'll get to in a minute, as a way to gradually introduce this physical posture. Briefly, so that is, oh yeah, I wanted to show you an example of these areas that we're talking about. The epilarynx can be stretched as narrow as 0.2 centimeters squared. That's the size of one of those small straws you've got. Tiny. To think about your voice coming through that, it kind of puts into perspective the importance of the vocal tract in tuning the voice. And 3 square centimeters is about the size of an O vowel. Tietze found that when you structure your vocal tract in approximately this ratio, from small to large, that's when it operates the most efficiently. Obviously, we can't sing with a semi-occluded vocal tract all the time. It wouldn't be very loud. So the mouth does have to be open. And he describes it as a trumpet.